Okay, let's take a look at page 377 in your workbook. So simplifying rational expressions, part 2. So it's just an extension of doing the same thing. Just the examples in this particular case are a little bit more complex. So a reminder that is important enough to state again is remember to simplify. You want to cancel factors, not terms. So terms, remember, are what you are adding or subtracting. Factors is what you are multiplying. Okay, so just it's factor, 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 and factor again. So why don't you guys take a moment and work through class example number 1, and if you want to hit pause, and once you've completed A, B, and C, then you can check in with the video again. Okay, let's talk these through then. So remembering in example number A, or letter A, we have a common factor of t that we can take out. Conveniently then we're left with two terms in the numerator, which are a difference of squares. We factor that to 2t minus 3 and 2t plus 3. So then we can see conveniently we have a common factor of t and a common factor of 2t minus 3. So that leaves us with just 2t plus 3, and the condition of that answer is that t is not equal to 0. So we need to set restrictions again for every factor that is in the denominator that includes a variable. So the first one is t, so t cannot equal 0. The second one, 2t minus 3, cannot equal 0. And so looking at t in that case, add 3, divide by 2, so t cannot equal 3/2. For the second one, we need to factor both of those. The top one is one of those ones where you have to be careful, because we can get 5x in two different ways, either by having the 3 with the 2x, or and having the x with the 1. But the key piece is going to be this sign right here. Because that's negative, then I need to make sure that my signs are different. Double check, triple check your factoring, because if you mess up your factoring, then your whole question is going to be incorrect. So make sure that you have done your factoring correctly. It's not just about getting the right numbers, the signs are important as well. Okay? So again, here we have a common factor of 2x minus 1, and so once we take those out, we're left with x plus 3 over x plus 1, x not equal to, then, if we look at this first one, adding 1, divide by 2, so x cannot equal 1/2, and then x cannot equal -1. In the second case, the numerator factors quite nicely to a plus 4 and a minus 2. The denominator is a trinomial. This is a to the 4th and a squared, so I know it's going to be a squared times a squared, and conveniently it's going to end up being a difference of squares, where I have two different difference of squares, a squared minus 4 and a squared minus 16. And so we will factor those then. Okay? So one important thing to keep in mind, it's one of these funny little things, but if you're having difficulties factoring, always look at ones that you've already factored as a clue. It's one of those things where, yes, you are learning how to simplify rational expressions, and because of that, there's a very good likelihood that something is going to be able to be canceled out. And so there will be a common factor, so try to look for what that commonality might have. If you're not sure, start with what are you going to factor more easily? Okay, and so even going back to the second example right here, if I know for sure the denominator has a 2x minus 1 and x plus 1, I'm looking at the numerator and saying, is it 2x with the 3 in the same bracket, or is it 3 in the other bracket? Well, if the 3 was in the same bracket, then there's no way that I'm going to be able to reduce that. So that might be something else that you're playing with, as well as a possible clue. So please keep that in mind. Okay, let's take a look at class example number 2. So key thing right here is, and I know we've had lots of talks about having things in ascending order versus descending order. So remember that if I have, for example, x minus 3, if I factor out a -1, that is the same then as negative x plus 3. And then if I rearrange it, it's -1, so that my leading number is positive, so then it's 3 minus x. So you can see from x minus 3 to 3 minus x, they are exactly opposite, where the x is positive here, the x is negative here, the 3 is negative, the 3 is positive. And so if we see ones that are exactly opposite, we can factor out a -1 to make them the same. So that's it exactly right here. Is that if I wanted to show the step, I could say that this is the same as -1 of negative c plus 4, and in the denominator I have 4 minus c, and negative c plus 4 is the same as 4 minus c, and therefore I can factor those out as 1 over 1, and therefore my answer is simply -1. Okay, the other way to go about it that perhaps is a little bit shorter is to not actually show the factoring of -1, just to recognize that these are exactly opposites right here in the question, and that I can say that I'm going to factor, and then rather than saying 1 over 1, that it's -1 over +1. Why not -1 over -1? Well, of course, -1 over -1 is just the same as 1 over 1. So it has to be -1 over 1. Okay, so the last thing that I'm forgetting right here is my restrictions. And so that would be that 4 minus c cannot equal 0, therefore c cannot equal 4. So take a moment and work through B and C. So hit pause and we'll come back to it in a moment. Okay, let's take a look at part B here. So we know that we can take 2 8s and reduce that to 1/4. And as well, p minus 2 and 2 minus p are exactly what we were talking about earlier as being opposites. So p positive here, -2 here, and positive 2 here, and -p here. So that means that we can factor them out, but rather than 1 over 1, we'll make it -1 over 1. So when we simplify that, then we've got just -p squared over 4. And that is, of course, conditional on our restrictions, and so our non-permissible values are our restrictions. 2 minus p cannot equal 0, therefore p cannot equal 2. Taking a look at C, once we've factored it, we're looking at 1 plus 2x and 2x plus 1 are of course the same thing, so we'll factor those out as 1 over 1, and so then we're left with 1 minus 2x over 3x minus 4, and that's conditional on x not equaling. And if you can't tell from here that it is -1/2, -1/2 and 4/3. Remember, you can always go to the side and say, well, 2x plus 1 cannot equal 0, and therefore 2x cannot equal -1. Divide both sides by 2. And so we can see clearly then x cannot equal -1/2. Similarly, 3x minus 4 cannot equal 0, so 3x cannot equal +4, and divide both sides by 3, so x cannot equal 4/3. Great. So let's take a look at this problem. So the area of a rectangular field can be represented by that expression, and the length of the field can be represented by this. So to find width, of course, we know then that area is equal to length times width, or of course that width can be found by taking area and dividing by length. So take a moment and work through A, B, and C, and we'll come back in a moment. So just hit pause. So taking a look at part A, so writing that rational expression which represents the width of the field. So we know width is equal to area divided by length. And so we set this up. We recognize that in order to simplify that, we of course have to factor it. So I know some people are thinking, oh no, trying to factor 12a squared. There are so many factors. What could it be? 12 and 1, 6 and 2, 3 and 4. But remember, the big clue is if it's going to simplify, one of the factors has to be 3a plus 7. So that's a really good place to start, is to try putting in 3a plus 7. And therefore, on the other side, we know that it has to be 4a. With the minus 7 here, it's got to be minus 1. And then expand and check that out. So that's 28a and minus 3a, which of course gives us our positive 25a. So that's correct. We can simplify the 3a plus 7s, and so we're left with a width of 4a minus 1. For a perimeter, we know perimeter is, well, can be represented in lots of ways: length plus width, or 2 length plus 2 width, or 2 times length plus width. And so I've chosen 2 times length plus width, and so that way I could divide the 2 out right away. So 27 then is equal to 7a plus 6, and simplifying that, a is of course then 3. So if the field has to be treated with fertilizer at a cost of $2.40 per square meter, calculate the cost of the treatment. And so what are we looking at here? Well, we need to figure out what the area is. So in terms of figuring out area, we could either have used the 12a squared plus 25a minus 7, which of course was given to us, or we could also have used the factored form 3a plus 7 times 4a minus 1. So either or. I chose to use the original. I knew that one was correct for sure, and so substitute in the value of a being 3 and determine that the area is 176 square meters, and at $2.40 per square meter it is then $422.40. Okay, so let's take a look at simplifying in class example number 4. Simplifying here exactly the same as before with x's and y's. Probably the most difficult part for people is stating your non-permissible values. So what do they mean is for x in terms of y is that your non-permissible values will look something like x cannot equal something y. So it might be simply x cannot equal y, or x cannot equal 2y, or 1/2 y, or so on. Okay, so how do we figure that out? Of course, we need to factor first, and then we can always take the time to do the inequalities, or the not equal for each of those factors. Okay, so let's take a moment, hit pause, and go through the factoring, and come back, and I'll go through the non-permissible values with you. Okay, let's take a look at part A. So you can see I haven't written anything down, and the reason for that is because it can't be simplified. If you notice, some of you may have been tempted to say that it's -1/1, but the problem is while our y's are opposite, the x's are not. The x's are both positive, so these are not actually opposites, and therefore it's not going to work. If you don't believe me, you can always try factoring out, and -1 out of x plus y, it ends up being -x minus y. So that's definitely not the same thing, and that's why that's not going to make a difference. So it is already simplified, x plus y over x minus y, and our restriction then, that is true. Well, we know that x minus y cannot equal 0, the denominator cannot equal 0. We want to find x in terms of y, so that means isolate x by adding y to each side, so x cannot equal y, and that is our restriction for that particular question. Taking a look at the second one, we've got x plus y, and we factored the difference of squares for the denominator, so x plus y over x plus y is 1 over 1, so we've got 1 over x minus 5y. Again, if we want to over the side, you can say that x, well, over the side, I just don't have room, so x minus 5y cannot equal 0, so isolating x by adding 5y to each side, so x cannot equal 5y, so that is your restriction there. Whoops, a little bit too small, there we go. So taking a look at part C, then, so we've factored out common factor of 3. That left us with a difference of squares of x to the 4th minus y to the 4th, and so we can make it x squared minus y squared times x squared plus y squared. Again, difference of squares with the x squared minus y squared, so x plus y, x minus y. X squared plus y squared is not a difference of squares, so it cannot be factored. If you wanted to expand x plus y all squared to x plus y times x plus y, that's fine. The alternative is when we simplify, we can say that 6 over 3 is the same as 2 over 1, and x plus y squared, well, one of these is gone, and that cancels with this one. So all I have in my numerator then is 2 times x plus y, and that is all over x minus y and x squared plus y squared. And there is absolutely no need to factor out or expand everything back in by any means. It's actually almost nicer to leave it factored, because then that way anybody looks at it, they know it's been factored, and there are no further steps that you can take. So for restrictions right here, we're looking at the fact that x minus y cannot equal 0. So again, for this, x cannot equal positive y, that's 1. And the second one is x squared plus y squared cannot equal 0, and so x squared cannot equal negative y squared. Okay? So, and that, of course, is unlikely to happen, because when you square it, it's not going to end up being a negative. So, okay, so please complete the questions that are assigned.